Welcome to ClickMyProject.com. Now we're going to discuss about the product comparing the dual mode VCSEL in OM4-MMF and GI-SMF links for NRZ, OK and 16 QM-OFDM transmissions. Now we're going to discuss about the abstract of the process. DM-OFDM is recently proposed where subcarriers are partitioned into an OFDM subblocks, divided into two groups within the each subblocks and modulated by two differential alphabets. In DM-OFDM, additional bits can be transmitted through the indices of subcarriers modulated by the same alphabets. In this letter, generalized OFDM, that is the DM-OFDM, then GDM-OFDM is proposed where the number of subcarriers modulated by the same constellation model in each subblock is alterable. By applying such enhancement, the spectral efficiency can be improved at the cost of marginal performance losses, that is the bit error rate. Moreover, since the bit error rate performance of the OFDM degrades as low signals to noise ratio, that is the SNRs, and then the interleaving technique is employed to address these issues. At the receiver side, the maximum likelihood detector and then the reduced complexity likelihood ratios, that is the LLR detector, are employed for demodulations. Simulation results demonstrate the proposed method is capable of enhancing the spectral efficiency compared with the other methods, and then the interleaved can be harvested on performance gain as well as reduce the bit error rate. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The process consists of the modules such as the input data, pre-processing, encoding, transmission, receiver, then output data, finally performance. So in the input data, the data will be generated randomly. So first of all, the node will be generated by means of the random position as well as the random values. After generating the random features, we have to do the pre-processing. In this pre-processing, signal limit will be there. So in case if the length of the signal is more, means the signal will be limited, or else the length of the signal will be the remains same. After that, we just move on to the encode step. In this encode step, first of all, we have to convert the data into one serial to parallel conversion. After the conversion of the serial to parallel, we have got the change in the data type. After changing in the data type, we just move on to the transmitter side. In this transmitter side, we have an two step. One is the BPSK and modulations. So by applying the BPSK and IFFT, we can get the data. Then it is modulated by means of the QAM. There is different kinds of QAM is applicable, that is the 16 QAM and 64 QAM. After applying these three techniques, we just move to the receiver side. Once the everything is completed up to the transmitter side, we just move to the receiver side. In this receiver side, it is the inverse of the transmission side. So in this receiver side, first of all, we have to decode the data by means of the again applying the BPSK and IFFT. In previous one, we are applying the IFFT. So in this one, we are going to apply the FFT method to inverse the data. So after the inverse the data, we have to retrieve the data, that is the output data. So the output data should be same as the input data. So we have to compare the output data with the input data. Then we have to generate the performance by means of the two kinds of performance parameters, that is the SNR and error rate. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B, then change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Now the GUI will be open, that is the graphical user interface. After that, you can select the button input data. Once you click the button input data, the input data will be automatically generated. The user need not to give any input. Automatically it will generate the random number and then the random pixels values. After that we have to do the encoding. So during the encoding you can see the results. This is the interleaving data, then encoded data, then binary to decimal conversion, that is the data type conversions. So these three things will be happen. So this is the main thing, input data versus the encoded data. After the encoding we just move to the third stage of the process, that is the modulations. In this modulation actually lot of intermediate result is there, like pilot insertion, zero padding, cyclic prefix, so lot of data will be there. So finally the data will be modulated. The modulated data will be looking like this, then the IFFT data will be looking like this. After that we have moved to the receiver side. So during the receiver side, first of all we have to notice the inverse process of the transmission is the receiver side. So the noisy signal, zero phasing, cyclic prefix, zero padding, FFT. So already we have applied the IFFT, so here we are applying the FFT, then pilot removal, interleaving, then finally decoded data. Now this is the decoded data. You can see the difference between the input and then the decoded data. Now this is the input data, encoded data. Now this is the decoded data. So we have to find out the performance of the process. So once you click the performance of the process, the performance like SNR and BER will be shown like this. Thanks for watching this video.